The Giant Magellan Telescope is predicted to be a revolutionary piece of technology. It's also a massive leap forward in humanity's journey to understand the secrets that lie in the universe. Anticipated to be built with 7 big mirrors working in perfect sync, the telescope will likely capture the clearest images that modern astronomers will ever see. It's also a plus that more than enough scientists are willing to contribute to this marvelous tech. Hopefully, this billion-dollar project in Chile's Atacama Desert will finally give answers to age-old questions that have continuously lingered in the minds of curious scientists all over the world. First and foremost, why did scientists choose this specific location? The simple answer lies in the fact that the Atacama Desert is a dreamlike setting for tech like the GMT. The desert is sitting at a high altitude, which means that it's well above many of the Earth's atmospheric disturbances. For this apparent reason, the assigned astronomers will get a clearer view of the beautiful night sky. Moreover, it has an incredible dry climate, so there would be no humidity to blur the images taken. There's also minimal light pollution from nearby cities, so the scientists wouldn't be distracted by external forces. Despite its barren condition, it's the home to an array of resilient flora and fauna, which means that these have adapted to survive in the most extreme conditions. The stunning scenery that it provides make it the perfect choice for travelers and scientists, proving to experts that it deserves its reputation as a natural wonder. When it comes to aesthetics, the telescope is likely to be just as amazing. At its heart are 7 huge 8.4-meter mirrors, crafted to work together and perform seamlessly. When they're aligned, these gigantic mirrors are engineered to form an effective aperture of 24.5 meters. It's a massive telescope, and that's understandable. Furthermore, GMT's enormous size will allow it to gather more light compared to other telescopes, revealing faint, distant objects with impressive clarity. With this technology, it's like we've built a new lens for humans to peer deeper into the cosmos, bringing us closer and closer to really understanding what's out there, only waiting to be discovered. However, the GMT wouldn't be as revolutionary if it weren't a true global effort. It has successfully united scientists and different resources from across the globe, with countries like the US, Australia, Brazil, South Korea, and Chile contributing what they can to bring unique expertise and passion to make this telescope a reality. The GMT has received significant funding from top universities, research institutes, and generous private donors who believe in its ability to push boundaries. So, are experts actually sure that the GMT will fulfill its mission without risks of failure? We aren't really sure, but it definitely holds incredible promise in what it can do for humanity. People are expecting it to unlock some very important secrets about dark matter and dark energy, which are 2 of the most profound mysteries in cosmology. Although these 2 forces are incredibly impactful with how the universe is shaped, they largely remain invisible and relatively unknown. However, because of the GMT's mirrors and grand resolution, the telescope is on track to help scientists in studying distant galaxies and cosmic structures influenced by dark matter. Who knows, it might even provide us some answers as to why the universe keeps on expanding. The telescope is projected to harness the power of an advanced version of data processing algorithms to efficiently manage the big volumes of information generated the moment it's put into use. If we're talking about professional use, data can be incredibly noisy since it's often filled with interference from sources that aren't really that needed. But anyway, to solve this issue, the engineers will employ upgraded techniques that help scientists filter out the unnecessary noise, focusing only on the signals that actually matter. This process is like going through a mountain of information to find those precious gems, the most relevant data expected to be preserved for further analyses. These advancements in data processing are not just about handling numbers, they're connecting the dots, helping us find more and more answers to our unending questions about the celestial realms. As researchers interpret these refined data sets, they'll be able to unmask connections between celestial bodies, providing a richer narrative about the origins and evolution of the universe we live in. Ultimately, the GMT's sophisticated data processing skills will not only enhance its technological power, but will inspire a deeper appreciation for discovery, igniting curiosity in all who engage with it, experts or not. Aside from dark energy and dark matter, scientists are also massively interested in exploring the possibility of extraterrestrial life. The Giant Magellan Telescope has a remarkable capacity to observe distant stars and their planetary systems. If scientists can study the atmospheres of certain exoplanets, they might finally identify chemical signatures, possibly indicative of water, oxygen, or biological life, giving us hints as to whether aliens are out there. On top of that, the telescope is intended to possess adaptive optics. That's a game changer since the images it captures will be clearer. As light from distant stars passes through Earth's atmosphere, it gets distorted by turbulence, making the images blurry. Nevertheless, the GMT employs adaptive optics technology that fixes these distortions in real time, adjusting the telescope's mirrors. This clever machine acts like a pair of glasses for the equipment, ensuring the picture quality remains intact. The Giant Magellan Telescope sounds like an exciting prospect, yet it also comes with its fair share of challenges, like every innovation that's been introduced to the world. One major issue is transporting its big mirrors, each weighing at least 20 tons, from facilities to the Atacama Desert. These important components have to be handled with a precise level of care, and their transportation has to be specialized to avoid damage. It can be tough to assemble the mirrors, as everything has to be really accurate. You can't afford to make mistakes. Additionally, it's not that easy for an international team of scientists and engineers from different nations and time zones to work together effectively. Yet, despite these issues, the shared passion and dedication of these scientists are expected to continuously fuel this remarkable collaboration, bringing the GMT closer to reality. The telescope is expected to have a phenomenal impact on scientific education and outreach, ushering in a new generation of experts and scientists. As one of the most outstanding innovations in the world, the GMT will undoubtedly assist educators, providing a valuable educational tool for students, enthusiasts, and the general public. Hopefully, this will encourage more youngsters to engage with STEM, the fields of science, technology, engineering, and mathematics. To ignite the modern astronomical revolution, educators can initiate the movement by conducting programs like internships, workshops, and summer camps, where students can learn about astronomy, astrophysics, and the technology behind telescopes. These informative experiences will demystify the field of astronomy, making it more accessible to the younger generation, inspiring them to take on a bigger role in scientific research. Likewise, the data the GMT is expected to gather will likely foster critical thinking and problem-solving skills in students, preparing them to tackle real-world practical challenges. As the Giant Magellan Telescope continues to be built, it's poised to provide unparalleled clarity and sensitivity. Together, let's watch as it paves the way for more advanced telescopes and stands as a testament to human curiosity and our relentless pursuit of knowledge beyond our world.